Hello Math 7 students, this is Open Up Resources, Unit 2, Lesson 10, Introducing Graphs of Proportional Relationships. This is part 2 in our two-part video series. I want you to remember what we did last time. Last time we had our PowerPoint where we were able to sort through all of our different cards, pairing them up with our tables, and then finding out whether or not they were proportional. So we had several that were proportional, several that were not, and to summarize, I've got all of that listed right here. These were the sets that were proportional, and these were the sets that were non-proportional. Here's what I'm going to ask you to do now. Now, I want you to focus just on the graphs. So, you can hide the tables instead of having them set out so that it's table and graph side by side, kind of like this. You can just put the table right in front. All that we care about is just the tables. But I want you to sort them so that we have all of the proportional tables kind of arranged so that we can see them all. And then all of the non-proportional tables sorted and organized so that we can see them. Take a second with your groups and work through that. Get all of your proportional tables and lay them out in one space. And in another spot on your table, get all of the non-proportional graphs and lay those out. Online learners, you can edit your own PowerPoint so that you can have a slide of just proportional graphs and another slide of just non-proportional graphs. So again, for you online learners, since we're just focusing on just the graphs, you can go ahead and get rid of just the tables. So you can just delete that table. I'm ungrouping these so that I can get rid of just that table because our focus is going to be just on these graphs. So whatever you need to do, get it to where you're just focusing on the graphs. Okay, now that everything is sorted, here's the next question that I have for you. Going back to our paper packet, what have you noticed about the graphs of the proportional relationships? In order to really notice something about the graphs of the proportional relationships, it helps if you kind of do a compare and contrast to the non-proportional relationships. So again, focus on these proportional relationships. What do you notice about the graphs? And then compare and contrast it to the non-proportional. Talk with your groups. This should take about 60 seconds to 2 minutes. Online learners, pause the video while you go through this and we'll return when you have your conclusion. Okay, let's come back together. What do you notice? Here's all of the proportional graphs. What is something that you noticed with your groups? Trinity. Yeah, just the proportional for right now. Let's move to Gavin. Very good. They're all in a straight line. You notice two things that are really, really important and worth mentioning separately. Straight line. Last year, I told you a word that we could use that represents straight line. Who remembers that word? Good. What is that word, Miley? Good. Linear is how you would say it. But yes, it's the word line and then the AR at the end. Linear, which means straight line. So let's take a look at that. All of these points lie in a straight line. See that? It's beautiful. Only I need to fix this one because I didn't do that one perfectly. And I'm glad that Gavin mentioned the other part too. I'm not going to write it down just yet. He noticed something else. And it's important because when I come over here and I look at these non-proportional ones, is this one in a straight line? No, that one doesn't work. What about this one? Definitely not. This one? Mostly, there's a few that don't lie on that line, right? But no, it doesn't work. What about this one? Yeah, that one is linear. And what about this one? Yeah. So, just recognizing that it's a straight line or that it's linear isn't quite enough. There's another characteristic which Gavin did notice and he said it out loud. But if anyone else didn't hear, I want you guys to have another chance and compare, focusing on what do these 5 all have in common that's different than these 2? Look at it one more time and discuss one more time with your group. Find that one other characteristic. Okay. Sounds like we had some good discussion. The other thing that Gavin mentioned is really important. Who can tell what that other thing is now that you have another chance to look at it? What do you see, Jada? Good. I like what you said, but I want to correct it. They're not all technically starting from the 0. In fact, none of them are, right? This one starts here at 1/1/3. But could we pull it back so that it goes through the origin? Yep. What about this one? It doesn't technically start at 0, 0, but could I pull it back? Yep, and it does go through. And if I pull this one back, what point does it go through? Surprise, surprise, it goes through the origin. And this one, if I pull it back, what does it go through? Goes through the origin. Let me fix that. It's not quite right. There we go. And this one, when I pull it back, it goes through 0, 0, the origin. So let's write that one down as well. Straight line, which means linear, and they can go through the origin. Did they all in the beginning? No, but can they go through the origin? Yes. So that point is the point 0, 0. That point, though, has a special name, and that name is the origin. The origin just means the point 0, 0. But we're going to write that down in a different place. We're going to write it down on our paper right here. What have you noticed about the graphs of those proportional relationships? They are all straight lines. That can go through the origin. Yes, Trinity? Yes. Yep, they both had 5 sets in them. That can go through the origin, which is the point 0, 0. So these are 2 really, really important characteristics. The next question is, do you think that this will hold true for all graphs of proportional relationships? Or do you think that I just chose these specific ones that I knew for sure would work? Will it work for all proportions? Quick 30-second discussion. Ready, set, go. Okay. That's, what do you think, Danny? Is it going to hold true for all proportions? Danny, is it going to hold true for all proportions? I gave you lots of discussion time. Turn to talk to your table now. Is it going to hold true for all proportions? Jackson, why? Because why? Okay, some might be angled in a different way. That's an interesting thought. Let's take a look at all of these ones that we see here. Aren't they all angled in different ways? But what's the one thing that we have common for all? They all still go through the origin, even though they're all angled different ways, right? Have I convinced you otherwise then, Jackson? So is it going to be true for all? Eyes on the screen. Eyes on the screen. Voice is off. Here is one that was proportional. Since we've noticed that they would be straight lines that go through the origin, that means that this point right here should be on the graph. That's the point 0, 0. So that means I could plug in a 0 here, and how do I go across this table everywhere on this table? What happens when I take a 0? and I multiply it by 8, what do I get? I'm going to get 0. Worked there. Let's look at another example that's proportional. Again, this is a straight line that can go backwards through the origin. Let's see if that actually makes sense. Can it go through this point here? That means that when this is 0, I go forward across the table by multiplying by 1/3 in this table, and 0 times 1/3 is 0. Any number times 0 is always going to be 0. So it doesn't matter if I'm multiplying by 1/3 or up here I'm multiplying by 8. When I take a 0 and multiply it by any number, I'm still going to get a 0. So we are going to see this for all proportional graphs. Will we see this for all proportional graphs? Yes, because 0 times k, remember k represents our constant of proportionality. 0 times any number is always going to be equal to 0. Therefore, it's always going to go through the origin. We're going to skip the "Are you ready for more" for the sake of time. It's time to summarize. One way to represent a proportional relationship is with the graph. Here is a graph that represents different amounts that fit the situation. The blueberries cost $6 per pound. So you can see that we can buy 1 pound of blueberries and it would cost $6. And if I buy 2 pounds of blueberries, it would cost $12. And if I buy 3 pounds of blueberries, that would cost $18. But what if I didn't want to buy 4 pounds of blueberries? What if it's 4.5 pounds of blueberries? Is it okay to buy half a pound of blueberries? Yeah, it is. That would cost us $27. I'll wait. This next part is something that we may or may not have talked about. I'm not 100% sure. But it tells us that sometimes it makes sense to connect the points with the line. Sometimes it doesn't. Let's talk about what that really truly means. If we can connect these points with a line, then that means I can buy not just 1, 2, or 3 pounds of blueberries, but I can buy half a pound. Does it make sense to buy half a pound of blueberries? Why doesn't it make sense to buy half a pound of blueberries? What if you don't want a full pound? Can you buy half a pound? Yeah, so does it make sense to buy half a pound of blueberries? I'm going to go ahead and say yes, it does. What if I didn't want half a pound because it's just me and no one else in my family likes it? Could I buy a 1/4 pound of blueberries? Is that okay? What if I wanted to buy 1.1 pounds of blueberries? Is that okay? Now let's compare and contrast this to our very beginning one. I know we talked about this. Can you buy half of a t-shirt? Can you buy half of a t-shirt? Can you buy 1/10 of a t-shirt? No. So please understand there is a difference. There are situations where it is okay to buy partial amounts, like blueberries, and it's not okay to buy partial amounts, like t-shirts. When we can buy those partial amounts, as it says in our summary, we can connect those points with a line because any number between the whole numbers makes sense for the situation. We can buy half a pound, we can buy a 1/4 pound, we can buy a 1.875 pounds. So any point on that line is meaningful. That's different than our t-shirts. We can't buy half a t-shirt. Just like this, if this graph represented the cost for different numbers of sandwiches, instead of pounds of blueberries, it might not make sense to connect the points with the line because you're not going to be able to buy 4.5 sandwiches or 1.875 sandwiches. However, Even if only some points make sense in a situation, sometimes we still connect them with the line anyway to make the relationship easier to see, because we want to be able to see that it's linear. So sometimes I would still connect them anyway. Here's the biggest takeaway. Graphs that represent proportional relationships all have a few things in common. Specifically, points that satisfy the relationship lie on a straight line. Remember that word? Linear. And the line that they pass on, or the line that they lie on, will pass through the origin. That's the point 0, 0. Here are some relationships that do not represent proportional relationships. This one doesn't represent a proportional relationship because these points do not lie on a line. I cannot draw a single straight line that will connect all of those points. So this one is non-proportional. This one is not proportional. Although it's linear, does it go through the origin? So yes, it's a line, but it doesn't go through the origin. It is now time for your cool down. Some of these graphs are proportional relationships, and some of them are not. We no longer have a table to look at. But you can tell just by looking at the graph whether it's proportional or not. Please read the directions carefully. Which graphs cannot represent a proportional relationship? Work with your groups. You have 60 seconds. Ready, set, go. Please come back together. Is A proportional? This is proportional. It is a straight line that can go back through the origin. B, is B proportional? Why? Doesn't go through the origin. It might be a straight line, but it is not proportional because it doesn't go through the origin. C, is this proportional? It is not a straight line, therefore it is not proportional. D is proportional because it is a straight line that does go through the origin. So to answer this question correctly, we should have written down B and C. Your homework problems are the Lesson 10 practice problems. They are due tomorrow when you return. That's it for today. Thanks for watching. We'll see you next time.